Let's look at specific experiments now, as we call them baseline, as we mentioned before. We need to start with a static baseline situation that is as simple as possible without losing crucial aspects of the problems that real appropriators face in the field. This static baseline situation is composed of these things. So basically, static means you don't want to vary too many things in the first set of experiments to get a good handle on the situation of self-governance in this context, in this action situation. But you also want to make sure that it is realistic enough compared to the real world, so that you're not doing some random experiment that has no value, right, for the real world. Participants, of course, set of n individuals. Now we have gone from 2 individuals to n individuals. My allergies are still bothering me. Positions, no differentiation exists in the positions of these participants. Hold, you know how you emphasize makes a difference. No differentiation exists in the positions these participants hold relevant to the common pool resource. In other words, there is only one position of resource appropriator. So each one has one position. It's not dynamic, it's static in that sense. Actions. Appropriators must decide how to allocate tokens assigned to them in each time period. Because it's an experiment, you deal with tokens. Basically, one can think of these appropriators as being endowed, so you get something for free to play, with a number of tokens E, which excuse me. Last time I moved this mic like this, I created some noise in the recording, so hopefully that's not happening. I'm using these things I bought from Amazon, and I've replaced them several times because they seem to have, you know, cheapish quality and tend to go bad in a while, but I have to constantly monitor to see if they're still working. There's a lot of work, but it's fun. Okay, actions. Appropriators must decide how to allocate tokens assigned to them in each time period. Basically, one can think of these appropriators as being endowed with a number of tokens E, which they are free to allocate in any proportion during each time period to each of the 2 activities. So the games are played multiple times, some rearrangements are made with the players and so on, but basically we will look at 2 activities, which means you are worrying about the common pool resource and you have other time to do your own thing. We'll see more clearly what that means, right? To simplify the problem, we posit that all appropriators have the same endowment, just as we all have only 24 hours sorry, per day, and face the same outside opportunity. Thus, each round they have to decide how much of their endowment to devote to appropriation from the common pool resource or in gaining returns from an outside activity. So you are doing something, gleaning something from the common pool resource, and in your other time out of 24 hours you are doing something else, which is presumably bringing you income in this context. For example, if each appropriator is given 10 tokens, for example 10 hours of labor, they can use 5 hours to go fishing, so using the common pool resource, and 5 hours working for a fixed wage. So you have an actual job where you work for 5 hours. Fishing is recreational come harvesting the common pool resource. So your responsibility and your role in the common pool resource is now together with your personal time to make your living. Outcomes then, the actions they take affects the amount of resource units that can be appropriated from the common pool resource, or returns earned from the outside option. Can you restrict the amount of time you can fish? Obviously, at least in the US, there are fishing licenses given and they have a season. Of course, it's not an ideal situation in this sense because they they stock this water bodies with trouts and so on, so that you can actually go fishing and find something. It's not a completely natural body of water. Fifth one, action outcome linkages here we use a mathematical function to translate the actions of all the appropriators into outcomes. While these actions are in reality frequently affected by many variables in addition to the actions of individuals, we will consider only simple deterministic relationships between appropriation actions and their effects on the resource in the baseline setting. For wage labor, the relationship function is simple. The amount of time allocated to wage labor is simply multiplied by the standard wage, number of hours times hourly wage. The resource function is a concave function f, which depends on the number of tokens x invested in harvesting the common pool resource. So concave upwards, concave downwards, basically that means your benefits can go up and after some time they drop. So this obviously is the case because you have multiple players, multiple actors in the action situation and arena, and what they do will determine the maximum benefit of the group as a whole. Initially, the sum of all of the individuals harvesting action, I again read it wrong. Initially, the sum of all of the individuals harvesting actions, sum of xi is each person's contribution to harvesting, generates better outcomes than safe investments in wage labor. So if you work, you are going to get paid. You know that. If you are harvesting a common pool resource like fishing, you may get a fish which may serve as dinner, but you may not catch a fish. So there is a guaranteed income and there is luck, chance involved in the other one. If the appropriators decide to allocate a sufficiently large amount of their available assets, such as time, to harvesting the common pool resource, the outcome they receive is less than the alternative. So there is an opportunity cost. In other words, allocating too many assets to harvesting the common pool resource is counterproductive. If everybody fishes all the time, then you know that that's going to be a problem. Information then, as an initial information condition, because of the instructions that are carefully given to all participants, because we're still doing an experiments either in the lab or in the field, we assume that appropriators know the shape of the function linking actions to outcomes and know that they are symmetric in their access to assets and opportunities. So everybody is following the same rules. There is equity. Information about outcomes is generated after each decision round is completed. Appropriators may not communicate with one another. It's assumed that each appropriator will assume that all other appropriators are rational actors and will adopt the best response as their own actions. If all players do in fact act as rational egoists, the best response functions should lead all appropriators to over-harvest from the resource. So everybody will maximize their self-interest and you end up with a tragedy of the common. The idea of preventing communication at this stage is to make sure that no side deals are made, no payoffs on the side are made to buy somebody else's quota of harvesting and so on and so forth, which spoils your basic premise of the experiment. Potential payoffs, then the payoff functions specify the value of the wage rate and the value of the resource units obtained from the common pool resource. Specifically, the payoffs to an appropriator is the payoff from wage labor plus payoff from using the common pool resource. If we call the total endowment of tokens, i.e. units of labor, E, and the wage omega or W, in this case wage W, then the payoff function is given by your wage times the time you spend. So if you don't do any common pool harvesting, then you're just working and getting wages. So your XI, or the time you put into harvesting the common pool resource, is 0. But if you put certain amount XI, then your endowment or your time out of the working hours, let's say 10 hours, is reduced. So your wage is reduced, but there is a return function associated with the time you're spending in harvesting the common pool resource, which is proportional to the total time put in by everybody. So that's the sum here, and the function, payoff function that we mentioned. So if Xi is 0, then your income is this complicated looking thing, but it's very simple. Wage times the time you put in, effort you put in, plus your effort compared to total effort times the return for harvesting the common pool resource, which amount of fish you catch and so on and so forth. Let's read this part and then come to the next podcast. Go to the next podcast. Basically, if appropriators put all of the assets into the fixed wage option, they receive a certain monetary return equal to the amount of their endowment times an unchanging rate of return W. If appropriators put some of their endowed assets into wage labor Xi and the rest in harvesting from the common pool resource, they get part of their return from the wage labor, which is this part, and the rest from their proportional harvest of the common pool resource as determined by this payoff function here. So of course these are all idealized situations, but it's a very powerful experiment to learn human behavior and self-governance. In fact, suppose participants receive 10 tokens or 10 hours of labor each round. A round could represent a day, so setting E equal to 10 is equivalent to allowing players to work 10 hours per day, which is this one. Then your return is very obvious. That we should share what share should we expect will be invested into the common pool resource that maximizes income of each player in the group. How do you know a priori what share of common pool resource harvesting will maximize the overall payoff, right? The function f here is depicted in the next figure. We'll look when we come back. For an experiment with 8 participants, you can see that as more people invest in harvesting the common pool resource, f will start declining at a certain point, which is why we call it a concave curve. Since f is the earnings people get from harvesting from the common pool resource, it follows that at a certain point participants will get less return if they keep on investing their efforts in harvesting the common resource. We use a value of 0.05 for W, which means that participants earned 5 real cents for each token used. So 1 times 0.05, so 5 real cents. Think of dollars, 0.5. Okay. For each token used for wage labor. Sounds complicated, but make sure you follow that. We are just having wage labor, which is directly proportional to the time you spend, and harvesting the common pool resource, which brings you income, but it's a bit more complicated on how that income is determined, because it depends on what everybody else is doing in harvesting the common pool resource and how the payoff function is defined. Okay, we'll come back and read this last part again when we look at the curve on the payoff function, but it's fairly self-explanatory as well. Okay, see you in the next podcast.